Hey everyone, let's look at these derivative problems, and this is what I expect your derivative questions to look like on this year's AP exam because everything is calculator active. You'll need to know how to do the product rules, quotient rules, chain rules, those types of things. However, they will word them in a way so that you cannot simply throw it in a calculator to get the answers, such as these problems. That's why I chose these, and you may recognize this from first semester, but they give you different functions. And for number one, we are to evaluate h prime of 0, and anytime you were to evaluate a derivative, you'll need to actually find the derivative. So this one, e to the x f of x, is a product rule. So that would be h prime of x would be the derivative of my first function, which would just be e to the x, leave my second function alone. Now I'll leave my first function alone and the derivative of my second. Since I don't know what f is, we will just generalize that as f prime of x. Then we plug in 0, and h prime of 0 would be e to the 0 f of 0 plus e to the 0 times f prime of 0. And e to the 0 is obviously 1. I hope that's obvious. F of 0, we pull that from the table. And just be very careful that you actually look at the right spot. At 0, f of x is equal to 5. Very easy to accidentally pull the wrong number from these tables. Plus e to the 0 again is 1. F prime of 0 is 9. 1 times 5 plus 1 times 9 is 14. But again, don't forget that on the AP exam, you're allowed to stop as soon as you have all numbers. You cannot stop with f of 0 and f prime of 0 because you don't know what those values are. You haven't written that down. But once you get to here, you can stop. So number 2, get rid of that. So here we have j prime of 1, same type thing. I would not let the negative 4 bother you. I'm going to ignore the negative 4 and do the derivative of f times g, which would just be your very definition of the product rule. So negative 4, and the derivative of f times g is f prime g plus f g prime. And some of you may have the ability to skip writing the actual derivative and go straight to, whoops, this is j prime, and go straight to this step that I'm writing right now. Negative 4 f prime of 1, g of 1, plus f of 1, g prime of 1. You may be able to skip straight to this step. I would advise you not to do that because it is very possible that they will give you a point for writing this step right here. And without writing that step, you may sacrifice points. So try not to skip steps, or don't skip steps in a free response situation. Write down every little step that you can. So now I'm down to evaluating, so that's negative 4 times, and then looking up at my table, I'm interested in f and g at x equals 1. So that's going to be this fourth row right here. So f of 1 is 3, g of 1, whoa, that's f prime of 1. Okay, see, there's where you need to be careful with your written work. My f prime kind of blended to a giant f, so I'm going to separate that. So it's f prime of 1, which is negative 3. And then g of 1 is 2, plus f of 1 is 3. G prime of 1 is 6. You're free to stop here. If you cleaned that up, that's negative 4 times negative 6 plus 18 is 12, which is an answer of negative 48. So here's the first two. Third one is going to be the most difficult, in my opinion, because we have a quotient rule with a product in the numerator. So this is a quotient with a product, so k prime, and now let's do it right here. So k prime is going to be low g of x, and d high is a product, so that will be the derivative of x times f of x plus leave the x alone times the derivative of f. So all of that is low d high minus high, which is f of x, d low is g prime, and then all of that over low, which is g of x squared. And now we have to plug in negative 2. So we'll take that and that leads to k prime of negative 2 is going to be g of negative 2 times, I'm not going to have room right here. Let's move this down. And this will probably have to go on the next page. All right, so g of negative 2 times 1 times f of negative 2 plus negative 2 times f prime of negative 2 minus negative 2, which will be plus 2 f of negative 2, g prime of negative 2, and then all of that over g of negative 2 squared. And, whoa, that's not what I meant to grab. Ah, it's not grouping. Oh, that's just lovely. Group. There we go. All right, and then let's plug in my values. So negative 2, I'm going to box. Oh, this is the top one. Okay, so top row is easy to see. So g of negative 2 is negative 5 times f of negative 2 is 3 minus 2 times f prime of negative 2 is 1. Then plus 2 times f is 3. And g prime is 8. All over g of negative 2, which is negative 5, squared. And I would just stop there. If you clean that up, let's see, so that's negative 5 plus 48 on top. So that's going to be 43 over 25. All righty. Let's see, I'll just scroll down and do this one. Okay, so here we have another product rule, only this time they've kind of moved the unknown. So again, we're going to start, it references L prime, so I'm going to have to find L prime. And this is going to be 3x squared g of x plus x cubed g prime of x. And then it references L prime of 2, so then L prime of 2 is equal to 3 times 2 squared is 4, times 3 is 12. G of 2 plus 2 cubed is 8, g prime of 2. And then they tell you that that is supposed to equal negative 48. So I can go ahead and say this equals negative 48. And now we have to pull these values from the table. So I'm going to look up and see if I can find g of 2 or g prime of 2. And g of 2 is 8. G prime of 2 is unknown, and that's the object of this question. So g of 2 is 8, so that's 12 times 8 plus 8 times g prime of 2 equals negative 48. And then this becomes algebra where we have to solve this equation. So 12 times 8 is 96 plus 8 g prime of 2 equals negative 48. Oh, crap. 48 and 96 is 144. So 8g prime. Is that right? Yeah. Is negative 144. And 144 divided by 8, I believe, is negative 16. No, it's negative 18. There we go. So there's your answer for g prime of 2. Of course, well, you'll have a calculator on the AP exam, but you could have left the answer as negative 144 divided by 8, which will be fine as well. Okay, last one. M of x is 1 over f of x cubed, and that is the notation for f of x cubed. Every now and then you'll see that written as f cubed of x, and they're both the same as putting brackets around the whole thing, which I kind of prefer doing that, just because it makes it a little bit more obvious what's being cubed here. But in this case, my numerator is a constant, and I've always stressed that if your numerator is a constant, to never do the quotient rule, bring the denominator up with a negative exponent and chain rule this. So I'm going to write this as f of x to the negative third power. Then my derivative gets significantly easier. m prime is going to be -3. Leave the inside alone. Subtract 1 from the exponent, so -3f to the -4, then times the derivative of the inside, so we chain rule it, times f prime. And that is a lot easier than any other options here. You could have done a quotient rule, but really in the quotient rule, you would have to do the chain anyway because you have all of f of x cubed. So just use the negative exponent, make things easier for yourself. Now I'm interested in m prime of -1, which would be -3 times f of -1 to the -4 power f prime of -1. And then we can plug in our values. At -1, f is equal to 9, f prime is equal to 7. So this will be -3 times -9 to the -4. Holy cow. And then f prime of 1, -1 is 7. I would not mess with that. Of course, you have calculators. I guess you could rewrite this -3 times 7 is -21 and move the -9 down. And I don't feel like dealing with 81 squared in my head, so I'm going to leave my answer like that for number 5, and I believe that was the last one.